Welcome to True Projects. In this video, we are going to explain about the project that is an improved ensemble method with data resampling for credit risk prediction. So before getting into the execution, first let us understand what is the project about. In the financial sector, lenders have frequently face situations where they must decide whether to approve a loan application or not. Imagine a bank evaluating hundreds of applications daily, while most are likely to repay, a few may default. So, accurately predicting which individuals are at risk of default is crucial because misjudging these cases can result in significant financial losses and also impact the institution's stability and also profitability. Here, the challenge lies in the complexity of financial data. Each applicant's profile is influenced by multiple factors, including their income, spending habits, credit history, and also broader economic conditions. So these factors interact in intricate ways, making it difficult to assess the risk using simple rules or traditional statistical methods. This scenario highlights the need for advanced analytical approaches that can interpret large, complex data sets and also provide reliable predictions for effective risk management. And here in the practical scenarios, banks often deal with a vast amount of financial data when evaluating loan applications. So, machine learning techniques are particularly useful in the context because they can process large data sets and also identify hidden patterns that indicate whether an applicant is likely to repay a loan or default. For example, machine learning models can analyze combinations of factors such as income, existing debts, spending habits, and past credit behavior to predict creditworthiness more accurately than the traditional methods. However, a common challenge in the credit risk assessment is that data sets are usually imbalanced. Here, the number of applications who default is much smaller compared to those who repay their loans. So, this imbalance can cause machine learning models to favor the majority class, that is, non defaulters, making them less effective at identifying potential defaulters. Therefore, handling this imbalance is essential to ensure the model can reliably detect high risk applicants, improving both the accuracy and also particularly usefulness of credit risk predictions. So, to tackle the challenges of credit risk prediction, the proposed system uses a stacked ensemble learning model. So, this project implements stacked ensemble, which combines several machine learning models to make more accurate predictions. So, in this setup, random forest, logistic regression, and CNN model act as a base learners. Each of these models bring unique strengths, that is, random forests provide robustness and handle complex nonlinear relationships, whereas logistic regression it offers fast, interpretable results, and CNNs excel at recognizing intricate patterns in the large high dimensional data. So these base models feed their inputs into a multi-layer perceptron, that is MLP model, which serves as a meta learner. This MLP integrates the predictions from all the base learners to produce a final decision, effectively combining their strengths and reducing individual weakness. This layered structure allows the system to analyze financial data more comprehensively and improve the accuracy and reliability of credit risk assessments. And here, one of the key challenges in the credit risk prediction is that the data sets are often imbalanced. That is, with a far fewer defaulters than the non defaulters. So, to address this, the system employs SMORT ENN technique. It's a hybrid resampling technique. SMORT, that is, synthetic minority oversampling technique. This generates artificial samples for the minority class. In this case, defaulters so here minority class is defaulters, so it will generate the artificial samples for this defaulters. While ENN, that is edited nearest neighbor, it removes potentially noisy or misclassified samples from the majority class. So here, by balancing the data set in this way, the model becomes more sensitive to identifying high risk applications, reducing bias towards the majority class. So this ensures that the predictions are fair and reliable, allowing the system to detect potential defaulters more accurately. The approach strengthens the overall framework for credit risk assessment, making it more robust than individual machine learning models. And to further improve the performance of this project integrates voting classifier, which combines bagging with a random forest and adabus with the decision tree. So this combines bagging with random forest and adabus with decision tree. So this ensures that predictions are fair and reliable. This ensemble approach takes the advantage of the strengths of both the methods, making the model more robust and also capable of generalizing better to different types of data. And here, to make the model decisions more transparent and understandable, explainable AI, that is XAI techniques such as LIME and SHAP were used. So these tools help to identify and visualize the features that have the greatest impact on the predictions, allowing users to see why the model makes certain decisions. In addition, a user-friendly front-end interface have been developed, which integrates Flask. So Flask has been used for developing the front end, enables users to input the data and view applications, that is view predictions directly. The interface also includes user authentication to protect data privacy and to ensure secure access, making the system practical. So this is what we have done in the project. I mean all the technical part. Now moving on to the flow of work, that is implementation. So these are the steps followed to implement this project. Let's understand each of them step by step. First, all the necessary Python libraries and packages are imported to handle data processing, model building, evaluation, visualization, and front-end integration. Then comes the next part, that is exploring the data sets. So here, the German and Australian credit data sets are examined to understand their structure, feature types, and also overall characteristics, including class distribution and basic statistics. Then comes data pre-processing. So here the data set is cleaned by removing null values, duplicates and outliers to ensure high quality input for the model training and to avoid skewed results. Then comes data balancing. So here the SMOTIN, that is SMOT ENN technique, is applied to handle class imbalance by generating synthetic samples for the defaulters and removing noisy for the majority class samples, improving model sensitivity. Then comes building and training the model. So here multiple machine learning models are developed, including ensemble methods and trained using the pre-processed and balanced data. Then comes model evaluation. So here we have evaluated all the models using accuracy, precision, recall, FN score, sensitivity, and specificity. So these are the metrics used to evaluate all the models trained, and those are visually represented through graphs. That means performance scores are individually represented through graphs. And the best performing model will be saved for the future use. And coming to the part of XAI, so here Lime and SHAP are employed to explain feature contributions and show which variable most influence the model's predictions, increasing transparency. And here, coming to the part of front end, here we have used Flask framework for developing the front end, that is to build user-friendly interface, including a registration and login system supported by SQLite to ensure secure and private access. Then comes user gives input as feature values. So here user the input feature values through the front end, providing the data needed for prediction. And that will be pre-processed at the back end. It will be fed to the trained model. Finally, outcome is displayed through the front end of the application. So this is how we have implemented the project. Now moving on to the algorithms used. So these are the algorithms used in this project. This is the proposed model and this is the extension model. So here we have the requirements. To implement, we need hardware and software requirements. In hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is all about the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open the code folder. So these are the source code files which are important for the project's execution. So here in this we have German data set. So this is the German credit card data. Let's open it. It's being opened. Just wait for a while. So here we have the records of the German credit data set. So here we have multiple attributes, that is age, sex, job, housing, saving account, checking account, and credit amount, duration, and purpose. So based on these features only, we will be predicting whether the person will default or not. So close this. And this data is used for training the models. Get back. And here in the model folder, we have the algorithm information that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for visual appeal. And here in this, we have Australian credit data set. And this is the templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And in this, we have test cases. So here we have test cases of Australian dataset as well as German dataset. Get back. And this is the app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And these two are the notebook files, which are Jupyter notebook files. They contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this is signup.db file. This file is a database file which is used to store the user information. And coming to this notebook file, so this German notebook file will load this German data, and then we will be training the models on that data and doing predictions separately for the German data itself. Coming to the Australian, here we will be loading this data and we will be doing data pre-processing and train the models only for this Australian data set. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. Copy it. Now open Anaconda prompt. It is open. So give the command cd, give the space and paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. So this command is used to execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port. So copy this local link provided by the Flask framework and paste it into any web browser. I have copied the link. Now I prefer Google Chrome, so I will paste it in that. Paste the link, click on enter. So this is the web page of the project, which is displayed in the browser. And this is developed using Flask framework. So we need to get registered first. Click on register and enter all the registration details if you have not registered the account. So I have already registered. I will directly sign in. Click on sign in. Give your username and the password. Now click on sign in. We have signed in successfully and redirected to prediction page of the project. So let's do prediction. Let's start doing prediction. First, let's do prediction for the German data set. So click on German. So here you can see parameters, right? These are the parameters need to be given as the input for predicting. So let's understand them. The first one we have is the age. This is the age of the applicant, usually in years. Then we have sex. It is nothing but the gender. That is it may be male or female. And then we have job. So here it is a type or the category of the application's occupation or employment status. Then we have housing. So it is the applicant's housing situation that may be own, rent, or free accommodation. Then we have it for saving account. So it is the status or balance range of the application's saving account. Then we have checking account. So it is the status or the balance of the application's checking current account. Then we have credit amount. It is the total loan amount requested by the applicant. And here we have duration. It is the loan repayment period, usually in months. And here we have purpose. That is the reason for requesting the loan, such as car, education, furniture, or other personal needs. So this is all about the parameters. Let's enter them. So let's open the test cases. So open test cases, open the German file. Now, so this will be the target column that we will be predicting. So let's apply filter to it. So let's apply filter to class false. Click on OK. And let's try with this case. So let's drag like this. And the age of the person is 67. And the gender is, sex is 1, that is male. Job value is 2. Housing is 1, which means it is free. Saving account is 4. So 4 is little. And checking account, it is 0. 0 is moderate, and credit amount is 1169. Duration is 6 months, and purpose is for 5. So here 5 value refers for repairs. Now click on predict. So this given information, it will be pre-processed at the backend, it will be fed it to the train model, and then train model will be giving us a prediction. So here we got the prediction result that it is low risk. So the person has low risk. So here credit risk is low. He is likely for eligible for the credit approval. Now let's check with some more cases. Click on German again. Let's enter them. So let's check with this case where the age is 48 and the gender is male. Job is 1 and housing is also 1. Sorry, that is 2. So housing 2 refers to own. Saving account, it is 0. So 0 is moderate. Checking account, it is also 0. So here also 0 refers to moderate. And credit amount is 2241 and duration is 10. Purpose 1. So 1 refers to domestic applications. Now click on predict. So here also you can observe that person has low risk. That means he is eligible for the credit approval. Now let's check with the other classes. So let's apply filter to class true. Click on OK. So let's check with this case. So let's start entering. So the age of the person is 22. Gender is female. Job value is 2. Housing value is 1, which refers to free. Saving account is 0, which is moderate. Checking is 1, that is rich. And then credit amount is 5951, that is 5,951. Duration is 48 months. Purpose is for repairs. That is 5 refers to repairs. Now click on predict. Here we got the prediction that it is high risk. Here you can observe the person has high risk. He is not eligible for giving the loan. So here we got the information that unfortunately his credit risk is high. So please review your financial details or the contact support. So it is predicting it as high risk. Now let's check for the other case. Click on German again. So now let's check with this case where age is 28, gender is male, job value is 3, housing is free, and saving account is 0, that is rich. And your credit amount is 5,234 and duration is 30. Purpose is 1, which is domestic applications, that is appliances. Now click on predict. So just wait for a while. Here we got the prediction that it is high risk. So here we are getting the prediction that is high risk. He is not eligible for giving the loan. Now let's check with the Australian dataset. So click on that. So here are the values that are to be given as the input. So we are supposed to enter them. Let's open the test cases. Open the Australian. So here are the feature values that we're supposed to give as input. Here we have the dataset features are anonymized. So the dataset features are anonymized as A1, A2, A3, A4, and A5 for the security purpose to protect sensitive financial information. So that is why we have named it as, the dataset has been named it as A1, A2, A3, and etc. So let's start entering them. Here, let's apply filter to target column. So first is class 0. Click on OK. And now let's start entering the values. So here A1 is 0, A2 is 29.58, A3 is 1.75, A1 is, that is A4 is 1, A5 is 4, A6 is also 4, A7 is 1.25, A8 is 0, A9 is 0, A10 is 0, and then A11 we have it as 1, A13 is 280, A14 is 1. Now click on predict. We have missed this field, that is A11, that is, sorry, here A12 is 2 and A11 is 1. Now click on predict. So here also information will be pre-processed and train model will be doing the prediction. So here we got the prediction that it is low risk. Let's check with the other case. So now let's check with this case where A1 is 1, A2 is 22.5, A3 is 0.125, A4 is 1, A5 is 4, A6 is 4, A7 is 0.125, A8 is 0, A9 is also 0, and A10 we have it as 0, A11 is also 0, A12 is 2, A13 is 200, and A14 is 71. Now click on predict. Here we got the prediction that it is low risk. So class 0 refers to low risk. The application is accurately predicting all the cases. Now let's check with the other case, that is class 1. Click on OK. And now let's try with this one where A1 is 0, 58.67, that is A2, A3 is 2, A4 is 11, A5 is 8. Sorry, we have entered it wrongly. So here A3 is 4.46. So A3 is 4.46 and A4 is 2, A5 is 11, A6 is 8, A7 it is 3.04, and A8 we are supposed to give as 1, A9 also 1, A10 is 6, and then A11 is 0, A12 is 2, 43, and 561. Click on predict. So here we can observe that application is predicting correctly that it is high risk. So class 1 refers to high risk. That is why application is predicting it as high risk based on the given transaction. That is based on the given data. Now let's check again with one more case. So now let's check with this case where A1 is 1, A2 is 32.75, A3 is 2, sorry, it is 1.5, A4 is 2, A5 is 13, and then A6 is 8. Then we have 5.5 as A7, A8 is 1, A9 is also 1, A10 is 3, A11 is 1, A12 is 2, A13 is 0, A14 is 1. Now click on predict. So here we got the prediction. It has high risk. So here the application is stating that with the given data, the person seems to be high risk. He may not pay the loan amount again. So this is how you need to do the prediction. Now let's check with the graphs for the German data set. So click on German. So here we have the sample outcome graph. So this is the sample outcome graph. Here on x-axis, we have the class label that we are predicting, and on y-axis, we have the count of each class. And this is the SHAP summary plot, which shows the feature importance for every target, that is for every attribute that we are using for doing prediction. Close it. And here we have it, SHAP model output. This is the SHAP model output value. And here, SHAP mean plot. So this is the SHAP mean plot. And here we have it for SHAP waterfall plot. And this is performance metrics. So here on x-axis, we have all the models that we have trained, and on y-axis, we have the scores of each model. So here each color represents one type of metric. So here blue color, this blue color represents accuracy, and this orange represents FN score, green represents recall, accordingly precision, sensitivity, and specificity. And here we have sharp dependence plot. So this is the sharp dependence plot. Accordingly, we will be having for the Austrian data set also, that is Australian data set. So here this is the sample outcome for the Austrian data set. Here on x-axis we have target value and on y-axis we have count. Close it. And here this is the sharp value. Close it. And here we have sample outcome. Sorry, this is sharp mean plot and this is model output value graph. And here we have performance metrics graph. And here we have sharp dependence plot. Now close this. Click on log out. In this way, just by giving all the parameters that are required parameters to the application will be accurately detecting the credit risk of a person. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.